All right, part 2. Let's see if we can get this done. So it says, what is cosine if sine of theta is negative 8/10 and theta, that means your reference angle, is in quadrant 3? Now they could throw that in any quadrant, but let's focus on quadrant 3. This is telling you that the opposite side is negative 8, the hypotenuse is 10. Now if you wanted to, you could reduce this to negative 4/5, and it's going to be fine, but let's stick with the original dimensions just because and see what happens. So quadrant 3, they're telling us the opposite side is negative 8 and the hypotenuse is 10. So that means my opposite side is going to, so here's, I know that if my spinner is 10, my opposite side is 8, but it has to be negative, which lines up because we're in quadrant 3. This is 1, 2, 3, and so it lines up with what they're asking. And some of you might not draw it proportionately. You might go like this. So this is 10, that's negative 8. That's fine, but your drawing's just not going to look proportionate. So anyways, we have, it's asking us to find cosine, which is a weird way of saying what's the adjacent side, which is this guy. Because if this is my reference angle, I know this is my opposite, I know this is my hypotenuse. To find cosine, I need this. So you've got options. You could go a squared plus b squared equals c squared. Let's go ahead and do that. A squared plus b squared equals c squared. So that's x squared plus 64 equals 100. So subtract 64 from both sides, we get 36. Take the square root, and we get 6. Now I don't know if this rings a bell, but that's the same thing. If we would have gone with negative 4 and 5, so that would have been 5, negative 4. Some of you would have went, that's a 3, 4, 5. But we found this to be 6, so this has to be negative 6 because it's left. So if we stick with this one, we'd go adjacent over hypotenuse, which is negative 6/10. But if we went with this drawing, we'd go adjacent over hypotenuse, which is negative 3/5. Now these are the same, but notice this is a multiple choice question, so we look for negative 6/10 or negative 3/5. We can see that that's option A. All right, so number 9. A car is on a Ferris wheel with a radius of 20 feet. So a big old Ferris wheel, it's going to go around and around. There it is. Radius 20. I'll just put it right there. To the nearest foot, how far does the car travel over an angle of pi over 3 radians? Now that's just 180 over 3, which is 60 degrees. Now some of you may have that memorized, and you probably should, but if you don't, that's how you get there. So if I tried to make it look somewhat like the drawing, that's 20. So this is 20, just throwing that in for free. They're saying how far does the car travel over this distance right here. So really they're saying find x. Well, if you remember back in the day, circumference equals pi d or 2 pi r, because 2 radii equal 1 diameter. I'll just use this one because we have a radius. So it's 2 times pi times our radius, which is 20, which is 40 times pi. If I get out my handy dandy calculator here, and I'm going to go 40 times, where's my pi button? There it is. It's blue. I don't know if you guys can see it. But second pi. Is that showing on the calculator? Yeah, there we go. And now I'm going to hit enter, and I get 125.66 feet. Now, if it's multiple choice, I bet you that'll be one of the choices. But we don't want that. We only want this. This is the entire, if this thing asked how far does it go in one rotation or revolution, that'd be my answer. But we only want 60 out of 360, because that's how many degrees are in a whole circle. which is 1/6. So we got to divide this by 6. Divided by 6, and we get approximately 20.94 feet. So that's a little kind of comes out of nowhere problem. All right, sharpen my pencil here a minute. All right, here we go. Look at that bad boy. This Ticonderoga is just taking a beating, but you gotta love a good Ticonderoga. All right, when the sun shines at 47 degrees to the ground, Talisa's shadow is 39 inches long. So you've got the sun. I don't know if my drawing is going to be really nice, but and here's Talisa, pretty gal, and then her shadow right here. I'm just going to make a triangle here. Her shadow right here is 39 inches long. That's her shadow. And of course our shadows are along the ground, okay? So, but the degree measure is 47. Now my drawing's not very good. That should be a lot bigger than that, but oh well. It says, write a function that models the height of Talisa. So this is my x. Her height is my x. So that's just a fancy way. I'm going to draw it more proportionately now. That's 47. This is her height. And we know that her shadow is 39 inches long. So it's saying write a function. Now we're talking trig function. So if we look at this, if this is our angle, this is our opposite side, this is our adjacent side, this is our hypotenuse. We're not going to use our hypotenuse. So in SOHCAHTOA, we know that hypotenuse is used in sine and cosine. Tangent uses opposite, and that's what we're trying to find. So we need it. And we've been given the adjacent side, which is right here, so it's telling you use tangent. So the answer to letter A would be tangent of 47 degrees is opposite over 39, adjacent. Now, that's the answer to A. To the nearest inch, how tall is Talisa? That's saying, solve this. Well, that's where our calculator comes in handy. Now, one of the things we have to remember is this is 47 degrees, so we better check our mode, make sure we're in degree mode. So if you're in radian mode, your calculator is going to really mess you up, and you're not going to know that it's messing you up. So make sure to change it to degree if you need to, but we're all set here. So I'm going to find tangent of 47 degrees is 1.07, we're going to call it. So 1.07 equals x over 39. Now how do we get home from there? Multiply by 39, because those cancel. Multiply that by 39. So I'm just going to hit times 39. Approximately, so x is approximately 41 point, what'd they say, to the nearest inch. To the nearest inch. So 41.82. The nearest inch would be 42 inches. So that's what they're kind of going for there in number 10. Number 11. What is the reference angle? Remember the rule. It's got to be sandwiched between the x-axis and the spinner. So we've got to take this, start with our spinner here. There's an invisible plus, which means up. So I just went 180. So I'm going to subtract 180 from this. And I'm going to end up with 84 degrees. I got to keep going. So that's going to keep going 84 degrees, which is almost 90. Now I got an 84 degree measure here. I've got a 6 degree measure here. Now which one of these is what they want, the reference angle? It's got to be this, because that's the one that's sandwiched between the x-axis and the spinner. Don't take the bait. No. All right. What about this one? Well, that negative means go down. Now we know that that's 90, 90, 90, which is 270, which means I need to keep going 11 degrees. So if that's 11 degrees, you might be tempted to take that as your reference angle, but that ain't your reference angle. This is. So that would mean 79. In other words, what plus 11 is 90? And that'd be 79 degrees. There's our reference angle. Almost done, you guys. So, number 12. It says convert the following to degrees. Now these are the easy ones. There's two ways to do this. The way I like to do it is say, hey, that's 45. I know pi over 4 by memory is 45. And so now I just have to go 3 times 45, which is 135 degrees. Now some of you might go, well, I remember that pi is 180, so I'm going to do it like this. And so 3 times 180 is 540 divided by 4. Guess what that is? So, however you get home from there, but hopefully you know that pi over 4 by now is 45. What about this? Pi over 9. That doesn't ring out as something we've memorized. So this one is where you might just want to go like this. Now I'm going to do it a little differently. Rather than multiply this, divide by 9, I'm going to divide 9 into 180, make that 20. 20 times 10 is 200, plus another one is 220. All right. Now, these, convert the following to radians. Leave answers in terms of pi. Okay, well, we'll talk about that in a minute. Well, 240 degrees, we should know that 30 degrees, which is pi over 6, goes into that. We know that 60 degrees, which is pi over 3, goes into that. So you'd say, well, 60 times what is 240? You'd say 4. So if I multiply that by 4, I'd have to multiply that by 4, so that'd be 4 pi over 3. If you use this one, 30 times what is 240? 8. So I have to multiply that by 8. So I'd get 8 pi over 6, which reduces to 4 pi over 3. So 4 pi over 3. Now, this guy, clearly 30 doesn't go into it, 60 doesn't go into it, 45 doesn't go into it. So we got to remember that pi over 180 equals 1. 180, that's degrees. 180 over pi equals 1. And remember the whole concept. We can multiply this by something that equals 1. We won't change its value. We're just going to change the way it looks. Now I'm going to write this a little different. 111.7 degrees over 1. That's this, written like this. I want my degrees to cancel because I want radians. I don't want degrees, so I want my degrees to cancel. So what I want is my degrees, 180 degrees in the bottom with pi on the top. I don't want this one. I want this one. So my degrees cancel, and now I would get 111.7 divided by 180. So I'm going to take care of that right now. 111.7 divided by 180. So this would end up being 0.62 pi. Now if you left it as 111.7 over 180 pi, there's nothing I can really do, but this is a little simpler version. Okay. Now let's go back to this one. What if none of this made sense to you? You can still multiply this one by pi over 180 degrees. Now, I didn't write the DEG this time, so I'm just going to cancel these degrees out. 240 divided by 180, well, 60 goes into that 4 times. 60 goes into that 3 times, so I still get 4 pi over 3 using this technique. All right, number 14, almost done. Evaluate all 6. So sine, cosine, tangent. Now if I remember, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now we got to spin our spinner 240. So we got to go up because that's positive. So 180 plus 60, make your drawing look somewhat accurate. So there's my reference angle. Finish your triangle there. That's my 30, that's my 90. This has to be 1. This has to be 2. This has to be my square root of 3. Now if you stop there, you're going to get all of these wrong because you forgot that's negative and that's negative. Well, now I got my dimensions. Sine, remember this is my reference angle, making this my opposite. This has to be my hypotenuse. This is my adjacent. Now it's easy street if you know SOHCAHTOA. Sine is opposite over hypotenuse. And if I flip that, I get 2 over the square root of 3. Now where do I put the negative typically? Now it should stay here, but negatives kind of stay in the top. We got to get that square root of 3 out of there. So negative 2 square root of 3 over 3. Cosine, adjacent over hypotenuse. Negative 1 over 2. This is a lot easier to flip because it's just negative 2. Tangent, opposite over adjacent. So that'd be negative square root of 3 over negative 1, which is just the square root of 3 because the negatives cancel. But if I flip this, I would get 1 over the square root of 3, but I got to get that out of there. Square root of 3 over 3, and there's my 6 trig functions. That's good practice. Okay. I'm going to stop this one because I'm at the 15-minute mark. Well, yeah, I'm gonna. And then this will be the bonus. So, with that being said, yeah, I'm going to stop the video right here.